Hello everyone, how are you? I hope you are liking this and let's begin. So, our intellectual war has not ended yet, but we are gonna having a tough decision that we are going to take is we're gonna skip the boards part for just this video, and in this video we're going to focus not on the rivalry, instead we are going to learn something. So we're going to learn about the atomic spectra. So what is atomic spectra, or you can call it a spectrum? I call it spectra. Actually, it does not make much difference. Just similar to everything, right? So what is atomic spectra? Atomic spectra is nothing, just a scale to measure the lines. Like in between, there is Balmer series, which is visible range for our human beings, for us. And before that we have infrared. After that we have ultraviolet rays. So this is just a scale and just nothing. Frequency scale, wavelength scale, whatever you like to call it as, just call it as. So there are few important people who gave few of the things in this, like Lyman, Balmer, Paschen, P Fund, and a lot more list. These are the names of the people. Can you believe that? We have to. Okay. So what does these things actually mean? Well, they have formed a formula and used a result. 1 divided by lambda is equal to R 1 by n1 square minus 1 by n2 square. So what are these? R is the Rydberg constant. Well, you can say this like this. Rydberg constant. I guess you know that, okay. And 1 and n2 are the orbits. So what this is going to tell us? Like imagine there are so many orbits. When in the fourth orbit, electron is sitting and it comes directly to the second orbit. So we are going to call it as Balmer series. Means this is discovered by Balmer. That what will going to happen when this is going to come in the first one. We're going to call it as Lyman series. So no matter where it is coming from, like even it is coming from the infinite orbit to the second orbit, we are still going to call it as Balmer series. And if it is coming from infinity to first orbit, we are going to call it as Lyman series. So we are just focused on what are the final results. So final result is the final thing for us. But this formula is going to tell us about the wave number, you can call it as, or 1 by lambda is a relation here that is figured out by the Rydberg, as you can see. So we're going to use this formula just for elaboration. We are going to learn this. So let's start. Like take an example that electron move from fourth orbit to second orbit or Balmer series. So what is going to be our lambda? So it's pretty much interesting, but pretty much simple too, as we have just one relation. So we have 1 by 4 square minus 1 by 2 square. That simple it is, right? So 1 by lambda can be figured out very easily. Rydberg constant is generally given in the question, so I'm not going to write its value to just make you feel a bit easier about the things. And we're gonna have something easier here. 16 is the LCM, 1 here minus, and here we are gonna write 4 multiplied Rydberg is 1 by lambda. Well, as you can see, I got a negative result, but that is okay. You know why? Because wavelength cannot be negative, so you can take it as positive. So I don't care wherever I write it and whatever my n1 and n2 are. I seriously don't care about that, because it will just change the signs, and I don't care about the signs because I'm always going to get the positive wavelength. So it's nothing to worry about. Okay, so this is the application of it. But what is its use? Interesting question. So if you figure out the lambda, what else you can find? Let me show you something. If I do something like this, 1 by n1 square minus 1 by n2 square. As you can see, what I have done is multiplied HC both the sides, nothing else. So what is going to change? Well, we're going to get the energy. So we have a new formula for the energy, which is HCR. All three are constant. H is a Planck's constant, C the speed of light, and R is Rydberg constant. And we have the orbit. So we can find not just the wave number or the wavelength, but we can also find the energy of the orbit. Or you can write it as delta E, because this is the change in energy we are going to measure from one orbit to another orbit, like second to one. So we're gonna get the change in energy. You can write it as E2 minus E1, like things like our delta E here can be E2 minus E1. So this is all about the thing, and you can remember Lyman's bracket, P1, Paschen, and all that things. That is not pretty much difficult. This is for first, second, third, and fourth, and so on. You do not need to remember all these things, just four is good enough. And that's it for this video. Take care, God bless, see ya.